We are now coming to the IBIS simulation. We have here prepared on the left-hand side a small example which consists of an IBIS sender, a transmission line of 50 millimeter length and 35 ohms characteristic impedance, Y crossing, a transmission line with 50 millimeter and 70 ohm, an IBIS receiver, and again a transmission line with 25 millimeters, 70 ohms, and another IBIS receiver. We have configured the simulation for a unit interval of 1 nanosecond. This means that a single bit has a duration of 1 nanosecond, depending on a single data rate clock or double data rate clock, meaning the clock frequency is either 1 gigahertz or 500 megahertz. But here we are simulating a data line. So we have an IBIS sender. This could, for example, be an FPGA, a microcontroller, or whatever. But in this simulation, we are just using the DDRM IBIS file, which we have examined a bit before. And we are using the shape pin out and have it assigned to the model pin DQ1. And what we have seen, it has a model selector of called IO, and it has a number of configurations. So we have chosen to take DQ40. We can also take DQ34, which just differs a bit in output impedance. Then the IBIS simulation is not a logic simulation, so it's a signals integrity simulation. Therefore, we have to assign a certain bit pattern to any output. The bit pattern, there are various possibilities. What we are taking here is a non-inverting randomized 1-bit pattern. And we are, for the time being, we are taking a minimum simulation configuration. Okay. The same we have done for the DRAM receivers. Again, right mouse click, choose PCBSim. Here the shape pin of this little symbol is in. The model pin is again a DQ pin. We could take any one. The IO type is this time an input, so we are not driving anything. Model selector is still the same IO. And here we have chosen an on-die termination of 60 ohms. And we have the same configuration for the second IBIS receiver. Now, to simulate this, very simply just click on Simulate Current Sheet and press the Simulate button. Now it starts to simulate, and what we will see here in a moment, we have probes on the output here, and we have probes on the input and on the cross point. The most interesting part really are the receiver side. So for the time being, I'm hiding the other signals, and now I'm zooming in, and it doesn't look too bad at all. So we have the cyan one is the receiver 2, the bottom side. The green one is the receiver 1 with the longer transmission line in front, so the signal is a bit later. And what we can do, for example, is we can select, or let us display the decision thresholds for low and high. Here we go. So we have 600 millivolts and 900 millivolts as decision thresholds. And we see that we are really fine. We have lots of safety margin and a very nice timing. And yes, so this is really as perfect as it can be. This is of course the case because we have approximately an output of 34 ohms. We have a transmission line of 35 ohms. We have this transmission line splitted into 2 lines of 70 ohms. So again, we have a match here. And then we have an on-die termination of approximately 60 ohm. So this is all perfectly matched, and it gives a very nice simulation result. Of course, if I change anything here, the results will be much worse. For example, if I'm taking an on-die termination of just 120 ohms for the receiver 1, that is. And we will see that the signals are really much worse for the DRAM 1. So you see huge overshoots here, or quite a bit of overshoots on the green line, which is the receiver 1. Okay, so what we have seen here is it is quite simple to make a simulation with IBIS, putting a sender and a receiver together, simulating the PCB in terms of transmission lines, and so having a very detailed input for the layout engineer saying this transmission line needs to be 50 millimeter and 35 ohm, 50 millimeter, 70 ohms, and so on. Thanks for watching. Bye for now.